Hello and welcome. Today I am going to show the data analysis using Minitab 17 software. And the important thing that I am going to say, that is outliers, the normality of the data set, and how can we perform the population mean when the population standard deviation is known, when the population standard deviation is unknown, and we can also able to calculate the population standard deviation for one population and for two population standard deviation. But before doing this, you have to install the Minitab software 17, at least for trial version or something like this, or if you can able to collect, definitely you should install in your computer, and after that you can proceed in this way. First I am going to show the outlier. Actually, in data analysis the identification of outlier, or the observations that fall outside the overall pattern of the data, is very important. It may be the result of a measurement or recording error, an observation from a different population. So, or we can say that this is an unusual extreme observation. So it is very difficult to identify which variable is an outlier, because the existence of outlier implies we cannot able to apply neither z interval procedure nor t interval procedure. So let me show how can we identify the presence of outlier in our data set. Suppose the data set is like this. Your data set 25, 26, 28, 31, 35, 39, 41, 42, 28, 29, 35, 38, and by mistake you have written 118, something like this. Okay, now we want to show how can we show this. Go to stat first, basic statistics, go to outlier test, variable, suppose the variable c1, if you write here c1, okay, c1, select, okay, this is the graphical plot, that one value lies extreme to the right. Okay, but our calculation also shows that null hypothesis, all data values come from the same normal population, and alternative hypothesis, the smallest or largest data value is an outlier with 5% level of significance. Therefore the groups test, through this test we can able to get the idea that yes, at p, that means probability value 0.000, we can reject the null hypothesis, and the outlier is that means 118 is an outlier. So our null hypothesis that all data values come from the same normal population is rejected, one outlier is there. So in this way we can able to calculate or locate or identify the presence of outlier. Now we are going to highlight, that means normality. Normality test is another important thing, whether our data has come from the same or the population which has some normal distribution, or the population is normally distributed, or the data, the sample has been taken from a population whose distribution is normal. Because if the population distribution is not normal, then again it will create some problem for the application of t test, t interval procedure, z interval procedure. So normality test also plays important role for our to apply the standard statistical tool. And how can we able to do this? Actually we have to plot the normal probability plot. In this plot, in one axis we have to plot the normal score, and you know how to calculate normal score, value of the variable minus its mean value divided by its standard deviation. And in the horizontal axis we can plot the value of the variable in arranged up in order of magnitude, that means from low value to lower value to higher value. So in this way you can plot this. Now And now I am going to show how can we test the presence of normality. So the normality test. Okay, I'm showing once again. Go to stat, basic statistics, go to normality test, then the variable is c1, this variable c1. Okay, click OK. Looks it should be like a straight line. Therefore our data has been taken from the population which may not be normally distributed. Now let's see, okay, how can we rectify this. First we change the outlier. Cancel the, drop the outlier value, and we can increase the sample size. Suppose 35, 54, 48, 47, 49, 51, 52, 56. In this way we can able to increase the sample size. Okay, suppose we want to take the 30 number of sample, because 30 represents sometimes the large sample size. So 30, 31. Now we want to check the normality test. Again go to stat, basic statistics, normality test, click normality variable c1, click OK. Look, is closely is a straight line. Okay, more the data set, actually we will get clear picture about the straight line. So if the data shows the straight line, if the normal probability plot shows the straight line, this implies that the data has been taken from the population which distributed normally. Okay, then we can able to apply our standard statistical tool. So this is normality test, that means the data has been taken from normal distribution. It is very very important before applying any statistical tool. Now I am going to show another thing, that is the Z sample test. Okay, Z sample test. So before going to apply Z sample test, let's do the basic, display the descriptive statistics of the variable c1. Descriptive statistics, because we need the mean value. So this is the descriptive statistics of this variable. Here mean is given, mean value is 45.29, standard deviation, sample standard deviation is given. Okay, now we are going to calculate the Z interval procedure. Z interval procedure, as you know, that we are going to calculate our confidence interval of the population mean from the sample mean when the population standard deviation is known. Okay, click here, the summarize data, sample size. Our sample size is 31, write 31 here. Sample mean is like this, 45.29, 45.29. Known standard deviation, since population standard deviation is known, suppose this is 4.58, suppose it is known, given. Now click OK. Okay, so confidence interval 43.674, 46.904. So within this range the population mean lies. This is the Z interval procedure. Similarly, on the basis of this data we can able to apply the T interval procedure also. In the T interval procedure we need to know the sample standard deviation, because in case of T interval procedure, since the population standard deviation is not known, the sample standard deviation may be taken as a proxy of the population standard deviation. So we can take the sample standard deviation as the population standard deviation. Okay, go to stat, basic statistics, T sample, go to summarize data, sample size we know 31, the sample mean we know 45.29, standard deviation. Now we can use standard deviation, sample standard deviation 15.72, 15.72. Click OK. So the according to Z interval procedure, the confidence interval now 39.5 to 51.06. That means the population mean will lie between these two values. So this is the T interval procedure. Now I am going to show the mean difference between two population. In my previous video I have given one example that the students appearing in joint entrance examination from the private school, and another population is students appearing in joint entrance examination from government aided school. Suppose the data has been collected, sample 1 maybe private school students, different school students, number of students appearing from one school, second school, third school, randomly selected. Similarly, number of students appearing in joint entrance examination from the government sponsored school. These are the two sample. Our objective is to investigate, does there exist mean difference in the population regarding the students appearing in joint entrance examination. How can we solve this? That means from the sample mean we have to predict the difference in population. How can we proceed? First, from descriptive statistics you can collect the data regarding mean and standard deviation of the two samples. Okay, here it is written sample 1, sample 2. Now go to stat, then 2 sample mean, click. Okay, in both the sample 31 sample size, sample mean 45.65 for the first sample right here. For the second sample this is 46.84. Now the standard deviation of the first sample, right, 16.02, 16.02, and another one is 14.58. Now click. Okay, the difference is p value is not significant, p value is 0.761. okay, that means we have to accept our null hypothesis that there is no mean difference between the two population. That means the students appearing in joint entrance examination in government sponsored or government aided school and the private school are same on average. Now we are going to show another thing, that is paired t-test. In my previous example I have given, previous video I have given one example regarding the mileage of petrol using Indian Oil as well as Reliance Oil. You can recall this one, but here I have taken this data, not exact data. Suppose the same individual once they have used Indian Oil and they recorded the mileage per liter, and again they have used the Reliance Oil and recorded the mileage per liter. So we have taken the sample here, and one thing you have to do, that is sample difference. What is the difference? Now proceed the pair. Since both the samples are related to particular individual, that is related, that is why it is paired. Okay, so paired. Summarize data. Sample size 31, right, 31. The sample mean means here sample is our difference. Okay, summarize data. So difference mean, suppose this mean difference is not calculated here, you have to calculate this difference mean. Suppose this is 15, suppose 15, and standard deviation also you have to calculate this mean and standard deviation of this difference. Suppose this is 3, suppose. So you have to calculate the difference, this variable mean and standard deviation, by using descriptive statistics. Now click. This means that the rejection of null hypothesis, because p value is significant, 0.000. So that means our null hypothesis that there is no mean difference, but that null hypothesis is rejected. We have to accept the alternative hypothesis, there does exist the mean difference between the two population. In our case there is a difference in mileage between using Indian Oil and using Reliance Oil. Now we are going to show how can we calculate the population proportion or confidence interval of population proportion from the sample proportion. So you want to investigate the confidence interval of the percentage of MA B.Ed candidate who got job in school as teacher in your own district. Therefore, naturally, you have surveyed one or two blocks of your district, and on the basis of that block, you got that out of 100 MA B.Ed, 40 got chance in school as teacher. Therefore, you want to calculate the confidence interval of this percentage with respect to your district. How can you proceed? You go to basic statistics, go to proportion. Okay, suppose this is 40, this is 40 MA B.Ed students got chance in teaching post out of 100. So 0.4 is your sample proportion. Okay, click OK. You will get the confidence interval. So in your district, 30.33 to 50.3 percentage of MA B.Ed got chance in school as teacher. So in this way, from sample proportion, we can able to calculate the confidence interval for the population proportion. Similarly, you want to calculate the two population proportion. Suppose the hypothesis is that male MA B.Ed students got more job in schools than female MA B.Ed. So naturally, you have two sample. Okay, from two population, one population belongs to the MA B.Ed candidate male, and another population belongs to MA B.Ed female. So from these two population, you have collected some data and you plot the data into this way: two population proportion, two sample, summarized data. Now sample 1, suppose 30 out of 100 MA B.Ed male. Okay, so got chance in job. And in sample 2, suppose this is 150 female MA B.Ed, and out of female MA B.Ed 150, suppose 38 got job in schools as teacher. So first sample 100 MA B.Ed male, out of 100 MA B.Ed male, 30 got job in school. Second sample is 150 MA B.Ed female, and out of 150 MA B.Ed, 38 got job in school as teacher. Your hypothesis is the percentage of MA B.Ed male who got job in school is same as the percentage of female MA B.Ed who got job in school as a teacher. So there is no difference in population. We want to investigate this hypothesis. Let's see what happens. So the result is this: the p-value is 0.421. Okay, on the basis of the p-value, we can take the decision. We have to accept our null hypothesis that there is no difference between male and female MA B.Ed who got chance in school as teacher. Had the value of p as less than 0.05, then we could reject the null hypothesis that there is that the population the male candidates, MA B.Ed candidates who got job in school are not same as the female MA B.Ed who got job in school. In this way, we can able to calculate. Even in the Fisher's exact test of p-value also shows that it is not significant. So we have to accept the null hypothesis. That is, there is no difference in your district of getting job. Now we are going to show that how can we calculate the population standard deviation from sample standard deviation. Suppose you have sample of one brand, or that means one company's LED lights lifetime. Okay, you have 50 samples, and you have calculated the average life, as well as you can calculate the standard deviation of that average life, okay, for brand 1. Now from that sample of 50, you have to generalize for the population of brand 1 about the lifetime of this bulb. How can you proceed? Go to basic statistics, go to variance, okay, standard deviation, sample size is 50, right here 50, standard deviation is 2.1, then click. So this is the confidence interval of standard deviation, this is the confidence interval of the population for its variance of the brand 1's LED bulb or LED tubes or LED lights life. Similarly, if we take another company, another brand's LED bulb, and we have taken the sample of 65 and their average life, as well as we can able to calculate the standard deviation of the average life. Now we want to compare that the standard deviation of brand 1 is equal to the standard deviation of brand 2 in population. How can we proceed? Just go to basic statistics, then to population variance, sample 1, the size is 50, right here 50, standard deviation is 2.1, right, 2.1, and for sample size 2, here you have to write 65, here you have to write 2.9. Our hypothesis is that there is no difference in standard deviation of the two population, that means brand 1 and brand 2. Click OK. So the result has come here, that using F statistic the test value is 0.02. That means we can reject our null hypothesis, that the null hypothesis there is no difference in standard deviation of the two brands, but we have to reject with respect to this result. That means it is less than 0.05. So we have to accept the alternative hypothesis. That means there exists the difference in standard deviations of the life of two brands LED light. The graphical plot also shows that had it been same, the ratio should have been 1, but the ratios are differs. So with this I am just concluding this video. Thank you.